All right, so now we've had a chance to multiply 9 through 12. And so you can see my work here and then my simplified answers. So in this one, I was hoping that you would notice, well, first of all of these I kind of had similar factors. Like this one had an X and a 4, and on the previous page it did as well. This we have the exact same terms, but one is when they're added together and one is when they're subtracted. And what I was hoping that you would notice is that what that happens when we do that is we have middle terms with opposite coefficients. And so what happens when they have opposite coefficients is that they cancel one another out. And that should have happened on all 4 expressions. And so what we're left with then is binomial. What we call this is a difference of squares. So the result is a difference of perfect squares. So what multiplication produces this? When you have things multiplied together and the first terms are identical and the second terms are identical, but one is addition and one is subtraction, the middle terms cancel out and we're going to be left with a squared minus b squared. And that's, in this case, again, like if I would have done the shortcut. See how I have 4x minus 4x plus 3. I'd say 4x squared, or 4x times 4x is 16x squared. The middle terms cancel out, minus 3 squared, or 9. Shortcuts. It doesn't mean that the box method or extended distributive property will not work, but it just helps us to recognize those things when we go backwards and we factor. So I'm going to do one of each type. So the first one that I'm going to try is this right here, number 2. Number 2 is this difference of squares. And so what's going to happen is those middle terms are going to cancel my shortcut, and I should be left with 25x squared. When I do the insides and the outsides, I have 20xy and negative 20xy. Those cancel, and I'm left with minus 16y squared. All right, I'm going to also do number 1. Another way that you're going to see number 1 is written. Number 1 is a perfect square trinomial when we multiply it out. So this is like this first case that we did at the top of page 12. Using the shortcut. When I multiply this out, the first term is going to be 49x squared. The middle term is doubled, meaning there's going to be 2 identical terms. They're each 7x, so 7x plus 7x is 14x. And then the last term is the last term squared plus 1. And finally, I am going to do the same thing. I'm going to do this one. There's no number on it. This is also a perfect square trinomial, but this time they're identical for subtraction. So not a difference of squares, but a square of a difference. So when this happens, first term squared, so 2x times 2x is 4x squared. The middle term is identical, so one middle term is minus 14x. If there's 2 of them, that would make 8x. And the last term squared would be plus 49. Okay, so now it's your turn. I would like you to try to use the shortcut. If you don't feel comfortable using the shortcut, then you should for now at least try to check answers using either the box method. And what I mean is the box method, for instance, if you did this, if I had 2x minus 7, 2x minus 7, watch what I get. Same thing. Okay. It's not like I'm doing something different. I'm trying to help you notice patterns here. But if you're really still struggling with what that pattern is, then just go back and do box method or extended distributive property. So you're going to page 13, check your answers, and then for homework, you're going to do pages 14 and